So now we're going to be looking at linear functions. So a dot is a zero-dimension thing. It's just a dot. Now a line, two dots make a line, or 2 points make a line. Any 2 points make a line as long as they're not on top of each other, like right overlapping. Then any 2 points make a line. Here are some more examples of lines. All the points lie on the same straight line of the thing. And here's more examples of straight lines, because we like straight lines. So the main formula for linear equations is the thing y equal to mx plus b. M is basically the slope. It rotates the slope up and down like that. You can do like that. It's not really clear, but it'll get more clear when we go into the coding. And then the B moves it up and down on the y-axis. It's like shifting it up and down. It will also be more clear when we start coding it. So let's start that. So first, before we get into that, let's start with the simple thing, just making a linear function. So here, first we start by making the function y1. The name is y1. So this is basically the identity function I did earlier in the video, so make sure you go watch that again. And also, so it's basically the identity function. So y1 is just basically returning x. So whatever x is, y is x. That's what it means. So let's create the x values. So this is just a name. You can name it anything you want, but we're naming it x values because it's clearer. And then the x values range from -20 to 20. And then we're timesing 1 to the x value, 1.0. That just makes like a 0.0 at the end because it's more clear. It just makes it into a double. So, and then if we submit the x values like that, we submit that, and then we do that, that will give us the code. So, -20 times 1.0, that's just 20.0. So these are all the x points that we're going to be plotting. And now to make the y points. The y values, the y1 value, the y values, basically like the straight line up, the verticals. It's the x values, and then this part basically means you're getting the x values and applying what you're calling the function y1 onto it, which just gives you the same thing because y1 is just the same thing as x, and like this function says. So if we get that, it should be the same thing as the x values. Now, if we put that into code, so this basically means, these two lines basically mean the x points are set to the x values. The x values are basically just this, that. So the x points are this, that, and the y values are basically this, the same thing, but the function y1 called upon it, which is basically this identity function. So it's the same thing. So now we can plot it out, and look, it says look 2020. See, just a straight vertical line. All the points are on the same line. And then the same thing, look. X is 20, Y is 20. X 20, Y 20. So that's what it means to plot the thing. So now we're going to make a different function. You remember the function y equal mx plus b? So this is x and this is the b. This b is shifting up and down on the y-axis. We'll show you more examples of this by changing the code. So first, we're adding 1 from x. This function basically is x, but plus 1. So the x values, x means x values here. X values, this. So it's this and this. So the y values equal the x value, which is up there. But instead of using the y1 function, we use the y2 function. So it's basically all the x values, but plus 1. Because of it, so it's all the x values plus 1. So that means this will be minus 29, this will be minus 28, this will be minus 27, and so on. That means, so now we set x values and y2 value because we changed the thing, and now look what we get. If we plot this, we get, look, 19, 30, 19, 29, 18. So this is the x values here. And yeah, so but now we're going to change the offset. So right now the offset here is 1. Let's change it to like 5 so you can see the changes. See, now when because we changed the offset, the lines always intersect at the point 5. The first intercept always at the point 5. Like here, -5 in this instant because it's plus in the thing, I'm pretty sure. So -5. We're doing the slope now, which is times x, which is a random number. So this function is called y3 because y value is 3. So y value is 3 is equal to x values, which is all the way up here. And it's adding the function y3, which means return 2 times x. So if we submit some code here and then do this, it should be like a giant line here because we changed the offset to like 100 over here. So we're just gonna decrease it back to 1, although it's gonna be too big. So here we go. Submit this again. Look, it's way smaller now. Here, from 9 to 100. So first we're gonna change this point to some more easier points to understand. Let's change this to -10 to 10 because it's easier. And there's some code. So here we have the line. Yeah. So you see this line, right? There is no offset because we didn't add one here. The offset is always at 0 because we never add one. But this is slightly sloped here, or the rotation. So we can make this a little more sloped if we change this. So let's see, we change it to 10. As you can see. So here is still the offset. So let's say the offset is, let's say 5. The slope is 5. See, look, now it will like slightly rotate in that direction. Let's change to something more obvious, like 10. Now it will rotate more clockwise. If you add a minus, it will basically just rotate the other direction, like this. So that's the slope. That's how you code linear functions. So the main equation for linear functions is the equation y equal to mx plus b. So m is like the slope. It's like the slope how it rotates, and b is like how up and down it moves on the y-axis. So I'm gonna change this to show you a few examples. So when m, or the slope, is equal to 1, you can see it rotates a bit like that. It went from the straight line a little bit upwards. Change to 5. Change it to 5. You can now see it's changing more for negative numbers. It does the same thing but the opposite way. So we put minus -5 here, -5. It's just basically rotating the other way. Now we will show you the offset. So the offset is how you move where the line intercepts on the y-axis, or basically just moving it up and down on the y-axis. So if we change this to like let's say 1, you can see it rises from the line a little bit by 1, but it's not very visible. So we'll increase it to like 10. As you can see, it has risen off the line by 10. The thing is, we can do both of them at the same time. So this can be 10, and this can also be 10. So as you can see, it's rotated by 10 from 0, and it's risen on the y-axis by 10. As you can see, it intercepts the y-axis at 10. This doesn't count because it's the x-axis, not the y-axis. The straight one up here is the y-axis, and that is the x-axis. So it intercepts on the y-axis. We can change this to like, let's say 50. As you can now see, it intercepts on 50. It's rotated by 10, and it intercepts the y-axis on 50.